This is the green team. My name is Jonathan Kropfinger.
And I am Brent Jett. Today we will be looking at an audio filter. This will be an adventure to say the least. What you're looking at right now is just an overall schematic of our circuit. The input and output, the circuits for those don't really matter because that's already taken care of with the system you're using. The input, as it's brought into the filter, is broken up into what's designated 3 channels, which is just these 3 filters here. Each filter outputs to these inverting amplifiers, which is then passed through into this summing amplifier over here, which then combines all those outputs into a single channel again. Now, all of these circuits are what are called active filters. Now, what that means is it just uses an op-amp instead of just the base components. Now, there are benefits to using active filters, such as the prevention of feedback, and overall it reduces the complexity of the transfer function of each circuit, which is how you determine how it's going to behave. Now, the inverting op-amps, if you look closely, you'll see these little symbols here with our pot. These are just potentiometers that allow us to change essentially how loud or how much of a signal comes through the filter in the final output. Alright, now that we've taken a quick look at the overall circuit, let's take a look in particular at the high-pass filter. Now, this is what was represented by that massive block in the previous picture. Now, these are all the same thing, which is shown here, which is just a Sallen-Key topography active filter. Now, Sallen-Key is just how all these components are set up, just like that. Now, the high-pass, it only allows the upper range of the treble, so any high-pitched noise like sirens in hip-hop or violins and flutes in classical, if you're whoever your musical taste is. Now, this in particular is a 6th order filter because we cascade or put in series these 3 Sallen-Key filters. Now, the reason it's 6th order is because the Sallen-Key at its very base is what's called a 2nd order filter, just because of the power of the transfer function. Now, as you can see down here, the components we used gave us a cutoff frequency of about 1.3 kilohertz. And that's all because of the 10 microfarad capacitors and the 12K and 24 kilo ohm resistors. Now, is anything below the cutoff frequency that you designed for will not be passed through. So any sound coming from the input below this will be completely cut out of the final output so long as the channel is on. Go.
So now we're going to take a look at our bandpass filter. We chose an RLC circuit, as you can see right here, for our bandpass filter. We took 3 RLC circuits made in this manner between these 2 circuits right here, and we cascaded them to one another. So we have a circuit here, here, and here. So this gives us an overall bandpass filter that's a 3rd order bandpass filter and has a decay of 60 decibels per decade. So the advantage of using the voltage buffer, as you can see here after our RLC circuit, is that we can take, to find the transfer function for our overall circuit, we can take the transfer function for this circuit, multiply it by the transfer function for the next circuit, and multiply it by the transfer function of the next circuit to be able to calculate our overall transfer function, which makes calculating our overall transfer function much easier than if we didn't have these voltage buffers. Our calculations would be extremely difficult to perform, and making a mistake would more than likely happen. So after we figure out the transfer function for our circuit right here for overall bandpass filter, we plug this into MATLAB and use the Bode function to make a Bode plot for our circuit. So as you can see here, we have a lower cutoff frequency of 145 Hertz. We have a center frequency of 409 Hertz, and we have a higher cutoff frequency of 1.2 kilohertz about. So we chose our cutoff frequencies very carefully so that they would overlap as close as possible to our high pass filter on this end and our low pass filter on this end. This is advantageous for our circuit so that we don't lose any frequency ranges from our input signal and end up losing a part of like a song or whatever you're trying to pass through these circuits.